Hello everyone. Yesterday, someone on my video commented that I make two good videos. I explain very well. However, I don't explain at all. I just upload raw code on YouTube Shorts. But still, someone commented like this, so I got little over motivated, and now I will start making solution videos too. The problem is we are given a number and we are supposed to count the number of ones in the binary expression of that number. For example, we are given a number, suppose we are given 6, then the binary expression of that will be 110. So we are supposed to number of
Count.
1 in that binary expression of given number n. So number of 1 in binary expression of 6 is 2, as we can see clearly. So we are supposed to count that for a given number n. So what we can do is simply use a mask. If you don't know masking, it's a technique in bit manipulation where what we do is we declare another temp variable. Let's use unsigned data type, because in integer data type we also have a sign bit, so that will be a bit of a headache. So I will declare an unsigned data type. I don't know what is spelling. Okay, unsigned. Let's call it 10, and its value will be 0b1. So this is our mark. So what we are going to do is we want to know how many ones are there, and to know this, actually I can write this 0b1 as something like this: 0001, because adding 0 before doesn't change the value of binary expression. So this and this are completely equivalent. So what I want to do is AND both of these. So if I AND both of these, what will happen is bitwise I want to use bitwise AND for both of these, which is this operator. So what it is going to do is bitwise apply bitwise AND on both of these, means it will apply AND on the last bit of this number, which is 1, and also plus and the last bit of this number, which will 1 and 1 gives a 1. So obviously we will get a 1 at the end. So we got a 1 at the end. Now for the second last number, which is 0 for this number, and it is 1 for this number. So when we will apply bitwise AND, we will get a 0, because 0 and 1 is 0. So and for rest of them it will also be 0, because 0 and 0 is obviously 0. So we will get this. So what will happen is, if we have a binary number with 1 at some index of its binary expression, and we AND with another number, then if it also has a 1 at that index, then it will result in a value which will not be 0, because there will somewhere be a set bit in this whole binary expression, so it will definitely not be 0. So what we will do is we will increase in next step. What we will do is remove this one from here and apply this one here. So now we have this expression. So if we apply AND again, then what we will get is 0 and this one 1. So because it had both indices, which is last and second last, so we got a number which is non-zero 2 times. But as soon as we convert our marks to something like this, now applying bitwise AND at both will give us a 000. And also if we convert the marks to this one, then we will still get 000. So obviously algorithm is now clear. What our algorithm is, we gonna move this one from the marks from left to right, or right to left. I have little bit of left side dyslexia, so sorry for that. So and moving the one from right to left, and keep noting how many times we got a non-zero number. The number of time I got a non-zero number will be equal to the number of set bits presenting this number. So that's the simple algorithm we're gonna follow. Simple bit manipulation algorithm. Hopefully algorithm is completely clear. So let's start coding this. So let's name this as mass instead of sense, because that makes it a bit more sense. So mass, and declare a for loop or while loop possibility. Okay, let's declare a for loop, and since we are given a constraint that n should be less than 10 to the power 9, so we can may easily go up to bit number 32. We will check up to bit number 32 how many ones are there, because it's smaller than 10 to the power 9, so obviously
So there can't be any set bit or any one after bit number 32.
Actually what is going to happen is, suppose instead of 32 bits we have a system where only 2 bits exist. Suppose integers are made of only 2 bits instead of 32 bits, or 3 bits. Let's assume that integers are made of 3 bits, not 32 bits. So and we already have this bit as assigned to be 1. So when we may shift it to leftward, what is this? Yeah, leftward. This time I am right. So when we shift this one to leftward, so what will happen is we get 1 here, is 0 here, and a 0 here. And once again, if we use a bitwise left shift, then what we will get is 0011. So can you see, just we when we had a 3-bit integer, we had to bit shift it twice to get to the last one, not thrice. So when we will be having 3-bit in 32-bit integers, we will have to apply bit shift operator only 31 times, not 32 times. So what we can do is, we can say that I know you can do like this also, that I equals to 0, then I less than 31. I understand this will also work, but I feel like if we write like this, that I equals to 32, but I start from 1, it will also run for 31 times. But it's a bit intuitive for me, so I'm going to go for this approach. So now let's think, this is the problem of a mobile phone. Coding is really tough. I'm not tough, it's just time taking, a little frustrating. And now I will, every time after doing some operation, I will at the end bit shift left the mask by 1. So okay, now we are supposed to OR it, and we want to count it. So first we have to declare a count variable, otherwise how will we be storing the count? We need some variable to implement this. Every time we use initialize it 0. So what I will say is, if n bitwise n mask, so whenever n and bitwise mask will return a non-zero number, that means we had a set bit at that index where mask had a 1. So means if mask had a set bit index at somewhere, then n also should have set bit at same index to return bitwise and as 1, otherwise it won't. So what we will do is increase the count variable. So every time we see that we got this bitwise ending as 1, we increase the count variable until unless we see through all 32 bits. So hopefully this would work. That's all needed. Hopefully it will work. Hopefully, because working at first glance, at first try is really hard. Oh wow, unbelievable! I can't believe my code ran at first try. Because beat manipulation already is very complicated. Let's try submitting it. Unbelievable, this happened first time probably. No, earlier also has happened, but this is pretty rare for me that it submitted at first try. I mean, I compiled it first time and it worked, and then I also submitted and it also worked at even first try, 100% accuracy. So hopefully you liked it and you're happy about I got it right.